Welcome to this essential language. Due to its simplicity and power, Python is one of the most widely used languages today, both by beginners and professionals. Why Python? An essential language to master today. It's used in various fields: web development, data analysis, artificial intelligence, automation, and more. A language to learn to progress in programming. Learning Python provides a solid foundation for exploring other, more advanced languages or technologies. Target audience: Python beginners or users of other languages. This course is designed for those new to Python, as well as those coming from JavaScript, Java, C++, and other languages. A simplified approach: one video per key topic. The goal is to remain clear and concise. Each video addresses one concept without overloading with information. Example: loops explained in seconds, then put into practice. We quickly introduce the theory, then immediately move on to concrete examples in the Python environment. Classic but effective content: numbers, lists, dictionaries, types, booleans. These basic structures are essential for manipulating data and understanding how the language works. File processing, functions, interfaces, tkinter, and databases. You will learn how to read/write files, create reusable functions, develop graphical interfaces, and store data permanently. Going further, using ollama to query an AI offline. Ollama allows you to run an AI model locally, without an internet connection, for more secure or private applications. Explore Google Colab and its built-in tools. Google Colab lets you code in the cloud for free with powerful tools like Jupyter notebooks. Sentiment analysis, mood detection, positive/negative. Using an AI example, we see how to automatically determine the emotion expressed in a text. Facial recognition, image comparison, and camera detection. We explore the basics of computer vision with a simple and accessible facial recognition project. Objective: to be able to create your projects in record time with concise, rapid, and directly applicable training. In Google, type Python and then click on download. And we will choose the operating system of our PC. For me, it is Windows. After downloading, we click on Setup to start the installation. I prefer to work on a personal PC. So we must check all users, all symbols and libraries to avoid errors. Otherwise, you type the same code and will have missing files. For the proper functioning of Python, we will give it all the administrations, all necessary authorizations. The installation went well. Now we will install a code explorer. I prefer PyCharm, so in Google I type PyCharm and then I start the installation. After downloading as usual, next. I'm giving feedback, I'm reading. I don't want to forward them, but prefer to associate the files with PyCharm. The installation of PyCharm went well, and new versions will always come to improve and facilitate programming. I start PyCharm. So I permit the program to work properly on my PC. I click on New Project and then on the terminal. I'm going to check that my program is working properly. I type Python 2 full version. Now I will install Anaconda. Why Anaconda? Because we are going to make an entry on scientific calculations. On machine learning, Anaconda is a popular distribution of specialized Python designed for data science. And also for machine learning and scientific calculations. After downloading, we simply click on Next and leave everything as default. At the end of the installation, we will open Anaconda in PyCharm. In the terminal, we type the code conda 2 times, then version, since the version is displayed, so our working environment is ready. Python supports standard arithmetic operations for numerical manipulation, similar to other programming languages. These operations include addition, subtraction, multiplication, division, exponentiation, modulo remainder, and floor division. They follow standard mathematical precedence rules and can be used with integers, floating point numbers, and more complex numeric types. The addition is simply, we will use the plus sign. We will go to C. One by one you will see that it is very simple, so I'm going to do a simple print here. We'll do 5 plus 2, for example. I will now execute it. And we can see that I have 7. So this is the arithmetic addition operator, which is very simple to understand. In the same style you have subtraction, which she will be indicated by the minus sign. Therefore, the operator will simply be the least. If I execute, we can see that my console displays 3 5 minus 2. Then multiplication. She will be obtained thanks to the star. So here, if I do a print 5 times 2, we get 10, and the last one quite simply, the split. With division it will be done with a slash. If I do 5 divided by 2, I execute this Python code, can see that I have 2 and a hat that are for the most common, so you don't need to be a genius mathematician to understand. These are really basic things. So then, something that is a little less common is the modulo. Then, the modulo is obtained with the percentage sign. So I'll explain to you how the modulo works. Simply returns if we want to simplify the remainder of a division or a Euclidean division, but well, we're not going to stop there. So let's imagine here that I draw a modulo, for example 10 modulo. Or what will be the result? That gives 2. So it's completely logical because it's the remainder of a division. To simplify, how much? Sometimes I have 4. In 10 we have 2. Because 2 times 4 equals 8, but if I multiply 3 times 4 gives 12, I exceed 10. So let's imagine here what I do, 10 modulo 5. If I run now a code, we can see that I have 0. It makes sense because 10 divided by 2 equals 5, and there is nothing left at all for my division. So automatically the return is 0, so that's it. Something that can be quite interesting later. Another thing, how to get power, simply with double star. So 10 to the power of 2. About women. 10 times 10. We can see that we have 100. Mathematical operators, you can see that they are simple to understand. It's not very complicated. There is no need to be a mathematician for that. So obviously, you will be able to perform calculations with numbers. For example, here, I could create a variable called nb1, which is equal to 6, is a variable nb2 which is equal to 0. So it works the same way. I could do a print of nb1 plus NB2. You can see that I have 8. So, what is also important to understand? If I do, for example, here, multiplication times 2, is that I have 10 as a result. So why? You can see that here, NB1 is equal to 6, and here, NB2 is equal to 2. Oh! How does Python calculate this? It will work the same way. That in mathematics, that is to say, multiplication, it has priority on the bill. In the same way that it would take priority over a subtraction, or that the division would also take priority over the addition or subtraction. That's to say, that here the calculation done by Python will be twice 2. At first it gives 4, which will be added to 6, so equal to 10. Now, let's imagine that I want to do NB1 plus NB2, that is 6. Norden. 2 is 8 times 2. I'm going to do a math priority. We put in parentheses 6 plus 2 makes 8 times 2. That is to say that here the priority will be first on NB1 plus NB2 and then will be multiplied by 2. And so there is the answer. East sees 6 plus 2 equals 8 times 2 equals 16. Something else that can be very interesting. You can obviously, for example, add a number, then go delete NB2, and we will keep NB1. Let's say I want to add 1 to NB1. So the value given to NB1, and we add a, which will allow me here. First of all, I will initialize the value of NB1, giving it a value 4, for example. So that will allow me to have 4 here for NB1. The assignment value plus 1 equal to 5. This notation here, we can replace it with another. More equals still. You will see that the result will be the same. NB1 plus equal and not equal plus different 1. You could see that it is indeed equal to 5. That is to say that in fact, NB1 will be added and we will increment by 1 to itself. So you should know that you can do the same thing here with less. So less equals 1. So I'm going to get 3 here. You can do this with multiplication and division. You can. Doing everything is no problem. So we will also use a term. When we add 1 to a variable, we will say more equal. And this term here means all that. To add 1 to a variable, it is the incremented term. When we are going to do less, so it's remove 1 to a variable, we call it decrement there. What there is to say at the level, there are not many mathematical operators. These are the most important ones. There are others, but these will help you want to discover in due time. But here are the main ones that we will learn in all programming languages to be able to do just that. Start making programs and playing with values. String manipulation in Python. You can retrieve individual characters from a string using indexing, which allows you to work with specific parts of the string. Slicing allows you to extract a portion of a string by specifying a range of indices. Although strings in Python are immutable, you can create modified versions of strings through concatenation or by using various transformation methods. To display a string in Python, simply create a variable. We will name it ch is equal hello world, and we put it in quotation marks. Then we execute it. Print is equal to ch to display. Now we will see the methods. Methods in Python are used to convert a string to uppercase, and if it was uppercase to lowercase, we can use replace to replace, join to join two words, and you can even count characters. Now we're going to use Upper to capitalize a string. Just put a point and then upper. We apply. Oh. Now we will interact with the user with input. Input allows you to request and retrieve user input. We store the result in a variable, name. Input, what's your name? Print name. First, we will print hello. Then we will print name. So at runtime, it will ask us for the name first. We will type the name, and then it will print hello. Followed by name. Already requested by the user. A concatenation is the merging of two strings in a single chain. We will use input from two strings. Dank on Vagarder. What is your name? Then we will create another variable. We'll call it pic. Python question. We will ask the user to respond. With input, are you a programmer? Now we will use a new technique for the print function. It is called the F string, or a formatted string. This is to combine all of them into one sentence. So F string, my name is, we will display the results of the name. And then automatically, we will take the result of pic. Add to that the fact that I am a programmer. So you always have to put braces between variables. By applying. So my name is Adele. Are you a programmer? I answer yes. The result est my name is Adele. Yes, I am a programmer. A list is a versatile and widely used data structure that stores an ordered collection of items. Being mutable, lists allow modifications to their contents after creation. In Python, lists support various operations for adding, removing, and accessing elements, making them essential for dynamic data handling. To create a list on Python, it does not need to be declared. We write directly color is equal. When we put brackets, so Python understands that it's a list. We will choose our list. It contains 4 colors. We put each color in quotation marks. Since it is a string, we chose the following colors: pink, red, orange, yellow. Since Python has underlined in red, there is an error to correct. There you go, 2 quotation marks are missing. So quite simply, on met the color variable between quotation marks and on execute to display the values of the list. This is the result. Now we select one element. Python always starts by the value 0. To choose yellow from our list, we put 3 in quotation marks, followed by a colon, which means from index 3 to the end. On execute, the result is yellow. Now we will try to add an item to the list. We use the append method as follows. Color points are appended, and between quotation marks, we put the color black. On execute, la function print color. The black color is good to add. Now we're going to remove an item from the list. We use the pop method for this. So, color point pop. The element index is a quoted character. On execute, the color red is removed from my list. We have already used concatenation between character strings. Now, we will use concatenation between 2 lists. We will rename the first list, and we will create the 12th list with different colors: green, gray, blue, white. I'll call you back. Colors in quotation marks separated by commas. Everything is in brackets. Now, we will create a variable. Colors that have a list of color 1 plus list color 2. Print color. We will execute our code. But first, we notice an error. Red color, so it is not recognized. Well, that's a typo. And we will execute. The colors list contains all elements of both lists. A set of 8 colors. Finally, we will use the replacement of an element of the list. So, with the global colors list, colors in brackets, the index is 0, so we point to the first value. Equal to in purple quotation marks. So the color pink must be replaced by the color purple. On execute, the color is well replaced. A dictionary is a mutable, unordered collection ordered in Python 3.7 plus of key-value pairs. Characteristics keys must be unique and immutable. Strings, numbers, tuples, values can be any Python object. Dynamic sizing. Common operations is insertion, modification, and deletion of key value pairs. Iteration over keys, values, or items. Dictionary comprehensions for creation. Transformation. Dictionary in Python. We will use fruits as an example for our dictionary. Fruits is an associated dictionary. As fruit names, fruits are keys, and their price, these are their values. The form of the dictionary is a continuation. We use braces. After the fruit, we put 2 points to express value, and a comma that separates the fruits. Quotation marks for the text fruit. And we put the value directly. For the prices, since they are numbers, we give different prices. For fruits, bananas, apple, avocados. To ensure that the variable fruits is a dictionary, we write print. Well, we open the parentheses. We write type, and I open the parentheses. Well, we write fewits. And we close the 2 parentheses. And we execute our code. The type is very classic. That is to say dictionary. And the values of our dictionary. It's displayed correctly. In Python, we can create a nested dictionary. That is 2 dictionaries in a single dictionary. We are going to delete all of that. And we're going to shout out a menu. Which is composed of 2 categories. A dictionary that contains foods with 4 dishes, and the price of each dish, and runs away with 3 types of fruits and their prices. Now, we're going to detail all of this. Menus are equal, we open the braces. Food is in single quotation marks. Well, colon and type. The first dictionary. Commonwealth fruits and the 12th. In the same way. And call the print function. We open the parentheses and type menus. And in brackets foo. And we close the parentheses. On execute, the food menu is displayed. The dishes and also the prices. Tuples in Python are ordered collections that can store multiple items of different data types, similar to lists. However, unlike lists, tuples are immutable. Their contents cannot be modified after creation. This immutability ensures data integrity, making tuples ideal for storing fixed or constant values that should not change during program execution. Tuples. Tuples are commonly used in databases. We will create a tuple that we will name home. We will give it a value of 1.80 square meters. It contains 3 bedrooms and a kitchen. We will give the location of this house. Home is a tuple that contains multiple elements of different types. We have an integer, it's 1, and we have strings 80 square meters, 3 rooms, a kitchen, and a list in brackets separated by a comma. We will print the home type to display the class, confirming that home is indeed a tuple. We will print home in brackets 4 to display the fifth element, index 4 of the tuple, which is the list of coordinates. Now, we're going to unpack the tuples. This is also called unpacking. It assigns values to variables in the form of tuples. We will create a number 1, number 2, and a text. So we have number 1 receives 2, number 2 receives 3, and the text always receives ADL between two quotation marks. We execute, so the display will show 2, 3, and ADL. Now, we are going to reassign a variable. In Python, you can change a value like a variable. So if we give him the text that is equal to cabbage, the same unpacking as before. But then we reassign the text variable with the value cabbage. The display shows that 2, 3 cabbage ADL original value is overwritten. Tuples in Python are ordered collections that can store multiple items of different data types, similar to lists. However, unlike lists, tuples are immutable, their contents cannot be modified after creation. This immutability ensures data integrity, making tuples ideal for storing fixed or constant values that should not change during program execution. Tuples. Tuples are commonly used in databases. We will create a tuple that we will name home. We will give it a value of 1.80 square meters. It contains 3 bedrooms and a kitchen. We will give the location of this house. Home is a tuple that contains multiple elements of different types. We have an integer, it's 1, and we have strings 80 square meters, 3 rooms, a kitchen, and a list in brackets separated by a comma. We will print the home type to display the class, confirming that home is indeed a tuple. We will print home in brackets 4 to display the fifth element, index 4 of the tuple, which is the list of coordinates. Now, we're going to unpack the tuples. This is also called unpacking. It assigns values to variables in the form of tuples. We will create a number 1, number 2, and a text. So we have number 1 receives 2, number 2 receives 3, and the text always receives ADL between two quotation marks. We execute, so the display will show 2, 3, and ADL. Now, we are going to reassign a variable. In Python, you can change a value like a variable. So if we give him the text that is equal to cabbage, the same unpacking as before. But then we reassign the text variable with the value cabbage. The display shows that 2, 3 cabbage ADL original value is overwritten. Booleans are a fundamental data type that represents binary truth values, true or false. They are essential for controlling program logic, enabling decision-making through conditional statements like if, repetition in loops like while, and evaluating expressions in logical operations such as and or not. Boolean always gives two values, either positive, which we call true, or negative, which we call false. We will create a variable number 1 we will call the input function, which always returns a string. So, even if we're going to ask the user to enter a number, we're going to check print type number 1. So we will see that input always gives the string class. So what are we going to do? We have to type number 1 equals integer number 1 so that the value is an integer. Now we have converted to an integer, we will create another variable. We will call it number 2. We will give it the value of 3. Number 2 is equal to integer number 2 to convert it to a number. Now, we will compare the two numbers. We compare whether number 2 is equal to number 1 with the double equals operator. The result will be true if the numbers are equal, false if the numbers are not equal. This is a Boolean operation that returns a Boolean true or false. That's why we're going to check with print type. As you see, for the integer class for number 1 and number 2, when we compare the two, we got a Boolean true value. Here we will change the value. Now we will give it 2, so it is different. We will execute. Then the value is false and the class is Boolean always. Variables serve as named storage locations in a program designed to hold data that may be accessed, modified, or referenced during execution. They provide a way to label and manage information dynamically, allowing the same memory address to store varying values as needed. Variables are fundamental for operations like calculations, decision-making, and data reuse, as their values can change in response to program logic or user input. Variables and their dynamic typing. First assignment, we will create a games variable and assign it a value of 150. We'll see the type and display the integer because 150 is an integer. Now we're going to change the type. Games is equal to addo cabbage. So we'll check the type and display. We reused the same games variable but this time with a string. The type has been changed. Games is equal between Hook, God of War, Uncharted, and Astrobot. We will check the type and display. Games is now assigned a list of games. Then, it will display the contents of the list. And then it will display the list class because it is a list. Comparison and conditional statements are fundamental constructs in programming that enable decision-making within code. Comparison operators are used to evaluate the relationship between two values. Conditional statements use these Boolean results to control the flow of the program. They execute specific blocks of code only when certain conditions are met. Comparison operations in Python. We will declare that number 1 is equal to 20 and number 2 is equal to 20. If number 1 is equal to number 2, then display number 1 is equal to number 2. We assign the value 20 to two variables, number 1 and number 2. F-string and two quotes, we open the brace number 1. We open the collide number 2 without equal. So, it will display the number 1 as equal to the number 2. Now we are going to make a condition with elif. So we give number 1 is equal to 20, number 2 is equal to 20. We let number 1 be equal to 2. And in the message that will be displayed, of course, it will display equally. Now, we will use else if. We will ask him the second condition, number 1 is different from number 2. If the first condition is false, then it is the second condition is true. And it will be displayed. A for loop is a control flow statement that enables repeated execution of a block of code by iterating over elements in an iterable object. An iterable is any object capable of returning its elements one at a time, allowing the loop to process each element sequentially. A for loop that iterates through a nested structure such as nested lists, dictionaries, or other iterables involves using one or more loops to traverse elements at different levels of depth. We're going to use a loop that will do the sum in a list, so I'm going to create a list. List is equal to 1, 2, 3, 4, so it is a list that contains 4 numbers. The number is equal to 0, so we initialize a variable number is equal to 0 to store the sum. For C in list for each element C in the list. Number is equal to number plus C. Add the value C to number and we will print for display the value of the number after each addition. We apply we know. That print number is in the loop. That's why it displays each time the sum of one element and the next element, and if we only want the final answer to at the end of the loop, you must remove the space and line break. Now, we're going to use a loop with a simple range. So we will increment from 0 to 4, so 5 elements since the 0 is counted. So we will proceed as follows for I in range between parentheses 5 and the explanation point. We will display the value of the variable I. We see that the result is 0, 1, 2, 3, 4. Now, we will make a specification. We will generate a sequence from 4 to 10 for I in range 4, 10. If we apply we see the value of 4, 5, 6, 7, 8, and 9. Here, we add another condition with a step of 2. So, we're going to add a comma inside the parenthesis again. If we apply, we will only have the values 4, 6, and 8. Now, we will add a condition. The loop executes normally as before. The block executes after. That the loop has completed its normal iteration, its break. The filing will be as follows. Four, 6, 8, and the for loop. A while loop is a control flow statement that allows a block of code to be executed repeatedly based on a given Boolean condition. The loop continues to run as long as the condition evaluates to true. Once the condition becomes false, the loop terminates, and the program proceeds to the next statement after the loop. A Boolean condition that is checked before each iteration. A code block that executes if the condition is true. The while loop with condition. We will do an initialization. We start by creating a value variable with the value 0, so the while loop executes as long as value is less than 3. At each extension, we increment the value by 1. Value is equal. We display the message. The value is less than 4, even if the condition is 3. The else block executes once the condition value is less than 3, becoming false. Displays value is greater than 3 because the loop stops when value is equal to 3. So the result displayed. Now, we will use the while loop with Boolean. We will do a password check. We will ask to do an infinite loop, while true, to create a loop that runs indefinitely. We will ask him to verify a password. Since there is a variable that is equal to input, the user will be asked to enter a password. Then it stores the input in the const variable. If the password is different from weight at 9, then it will display false password. Otherwise, it will display true password. To stop the infinite loop, we use break. We execute. So I type anything, false password, anything again. And now I'm going to type the correct password. but unfortunately, I did not type the correct password. Now, I start again with the correct password. Then it will display true password. In Python, a function is a self-contained block of code designed to perform a particular action. It encapsulates a set of instructions under a single name, allowing that block to be executed whenever needed by calling the function. Functions promote modularity by dividing a program into smaller, manageable sections, each responsible for a distinct operation. This improves code organization, readability, and maintainability. Additionally, functions enable reusability, as the same code can be invoked multiple times without duplication, reducing redundancy and enhancing efficiency. In Python, functions begin with def when you want to declare a function. Define a function called sum which takes two parameters nbr1 and nbr2 and then we will return the values of nbr1 plus nbr2. The function returns the sum of the two numbers passed as parameters. We will declare a variable var is equal sum 5, 10. Call the sum function with the arguments 5 and 10 and store the result 15. In the variable var, printf string sum is var displays the result as the formatted string sum is 15. Now, we will create another function. It will extract a name from a list. So we define check name, which takes the parameters list. If ideal in list, check if the ideal string is present in the list. If yes, display yes. Yes, no, please no. So, we're going to present our list. We're going to call it test is equal in brackets. Two quotation marks Adele, comma, cabbage, comma, Lily. This is a test list containing 3 elements. Check name test. Call the check name function with the test list as arguments like Adele. We execute, and in the list, the function will display yes. Let's test the second part of the code. We'll type a name that doesn't exist. For example, Susie. We execute it, and it displays no. On tape, Lily, and it displays yes. We're going to create a converter module. In a folder, we're going to type new Python file and we're going to call it converter. We will store two conversion functions inside. Def-conv kilometer to meter NBR. Its role is to convert a value in kilometers to 1 meter. NBR is a parameter representing the value in kilometers to convert. We will do a return NBR x 1000. Now, we will define another function, def convert meter to kilometer. We will return NBR divided by 1000 to convert a value in meters to kilometers. We are recording. Our module was created in the current folder. We import the converter module, which contains the conversion functions. The user is asked to enter a distance in kilometers with input. We will declare an NBR variable. Entrance, distance, kilometer. We convert the input, which is a string, to an integer with integer. We will create a variable called val, which will return the value of the converter module. Val is equal, function convert kilometer to meter of NBR value. We display the result with a formatted string. Distance in meters between two braces and execute. He will ask us for the value. We give him 5. The answer in meters is 5,000. For the conversion from meters to kilometers, it is the same principle. We are going to modify our code. Instead of entering the kilometer, we will enter the meter. Instead of using the kilometer to meter function, we will use the meter to kilometer function. In the f string, we will change the distance to 1 kilometer instead of 1 meter. We'll give her 5,000, and in return, she'll send us 5 kilometers. Packages are pre-programmed modules that we use as we go. We will try to go to the Python package and look for a Pixel example. We're going to install it. We will choose the latest version. Then we start the installation. The presence of the uninstall indicates that it is properly installed. Now we import the PyXL module under the alias PE. We will create a list of lists or a 3x3 matrix. We will declare a data variable which contains a list between lists. Braces, and each brace contains 3 numbers. In this brace, 1, 2, 3 and will be in the first line. Four, 5, and 6 in the second line, and the last list 7, 8, and 9 in the third line. Now we will save using the save as function to take our array data and equal data. The backup will be in an Excel file that we will name output.xlsx. We execute our Python code asking to install OpenPixel. Of course, we will go to the Python package and look for our file, then we start the installation. And we try again. Now we're going to see our file. The Excel file was created correctly with a 3x3 matrix. Object-oriented programming (OOP) is a programming paradigm centered around the concept of objects, which encapsulate both data attributes and behavior methods into self-contained units. OOP promotes modularity, reusability, and a clear structure by organizing code into classes and objects, making it easier to build and maintain complex systems. Class, a blueprint for creating objects, and object, an instance of a class with actual data. A class is a blueprint for creating objects. Here, we define a person's class as one that represents people. The init method is the constructor of the class that is called automatically when a new object is created. We will take 3 parameters: self, reference an instance, name, and age. We store the name and age as the object's attributes. And we access the name attribute via self-name and age via self-age. Creating the instance calls two methods. Person is equal. Person in parentheses and adel in quotation marks, commas. 30, which refers to age. We move on to the display. Print P1 point name. And we return to the display line P1 point age. The result is adel 30. We will now display the class differently. We will call other methods. To keep things simple, we keep the same person class with name and age. Now, we will define a simple method that displays a message with a person's name. My func self stu point print hello, my name is self point name. There is an error self point name and not selfs. P1 is equal, person in quotes adel in quotes 30. Return to line P1 point myphone. On execute hello my name is adel. Now we are going to make it change. P1 point name is equal to cabbage. We execute the change that has been made. tkinter is Python's built-in library for creating graphical user interfaces GUIs. It allows developers to build desktop applications with windows, buttons, menus, and other interactive elements. As a standard Python package, it is widely accessible without requiring additional installations. tkinter is platform-independent, working on Windows, Mac OS, and Linux. While it may lack some advanced features compared to other GUI frameworks, its simplicity makes it a practical choice for basic to intermediate desktop applications. We import the tkinter module to create graphical interfaces. Import tkinter as tk. For tkinter, we import a message box. We will insert a message box for display. Now, we will create a main window with tk. Root is equal to tk dot t capital K. And then we will give it a name. Root point title tkinter example. To display tkinter, simply type root point menu. To assign a size to the window, simply do root point geometry. And type in the length and width. Let's do it. Now, we are going to create a label. It is a text that is displayed on the screen. The label is equal to the tk point label. We will assign him a text. Label point pack. We will assign it a size using pd. We will run the default display and center it on the page. Now, we will create a button, which triggers an action when clicked. So, dev on button click. Message box point show info button click. Now, we will create the button widget. Button is equal to tk point button root text. Button is equal to tk point button root text command on button click. When the button is displayed, it will ask you to click. Click me. Now, we will give a size to the button. pd is equal to 30, and we execute. On click is response is button ratchet. So, the button is interacting with the user. We will make changes. We will delete the comments and the click button event code, too. Now, we will create an entry widget. To allow text entry, user input equals entry point get. The get function allows you to retrieve the entered text. Then the text entered is displayed in the dialog box. The rest works like the first example. We only change the message. After the F string, it will inform us that you have entered such value. so it will retrieve what we wrote in the text box. Then he will display it. We'll call it the tkinter entry example. For the size, we stay at 400,300. For the text, we'll ask him to enter something. For the label, we're sticking with 10. Now, we will launch the command. Entry is equal to tk point entry in parentheses root. The entry point pack is equal to payD 10. In a button, we will change the text to submit. For the size, we will give it 20. So check. I think everything is okay. Now we are going to execute. If I type hello adult cabbage and click the submit button, message box returns the values typed in the text box. Python offers built-in functionality for file handling, enabling operations such as reading, writing, and modifying file content. The process involves opening a file, performing the desired operations, and then closing it to ensure proper resource management. Files can be opened in different modes, such as read, write. Read, write allows both reading and writing. We will open a file in read mode. So, we write file is equal to open. The file name, example.txt, and R. Open the file example.txt in reading mode. Then we will use the file read. Now, we will create the contents variable. So, to read the contents of the file and store it. Then we will use file read. It reads the entire contents of the file and stores it in the variable. Then, we close the file with the file point close. This is important to free up resources. We execute, and the file is open with its contents. Now, we will move into write mode. So, the file point open, example.txt. And this time, we're going to put W. Please note that this mode overwrites existing content. File. Write strings to the file. /n creates a new line. And we always close with close. So, our hello world text will overwrite the already existing content. Now, we will use /n to create a new line. We add a line. This is a line. We execute and open the file. Both lines are added correctly. Now, we will work with binary files. So, we will use RB and WB mode. These are modes for reading and writing binary files like images. So, we use the open syntax, which automatically closes the file at the end of the block. Image with JPG extension between commas RB writing mode. We use binary, which receives binary data is equal to file read. Now, we will move on to writing mode. Always use with open. We will open our photo. But this time, we will use WB. And we will write the image as a copy. Tauger's file point write binary data. If we run while looking at the created file, the first file with 36 kilobytes, and so is the copy. Python offers various methods to interact with databases, ranging from simple file-based storage systems to complex relational database management systems. The approach depends on the type of database being used. In Python, databases can be categorized based on their structure, storage model, and usage. Here are the main types. In our example, we will create a database with SQLite, so we import SQLite 3. And then we will declare a connection variable con is equal to SQLite get we will call. The student's database extension .db. Now we have to create a cursor that we will name cur. Is equal to the cursor point connection, so it is the cursor that will move in our database, and we will create it with cursive execute the table between 3 quotation marks. Create table if not exist. This is very important, students, so if it exists, he must delete it. And create it again. Now we will create an ID integer primary key auto increment. That is to say, for each record it will increment by 1 return to the line. We will create the fields so last name in text format, first name also in text format. Age integer, and finally class text. After each record you must type comma. At the end we don't type a comma to tell him that we have finished our recording. Close our connection point close and we execute. We will go to the current folder. We see that a database has been created, and thanks to this free software DB browser. We will read the table that was created with the ID last name, first name, age, and class. The software is free and downloadable on Google. Now we will fill the database. That's why instead of creating we will insert. So I will formulate the command insert into students. After each record we put a comma. So we close the parenthesis. Now we will give the values to the field. That's why we will call values. We open the parenthesis since it is a text, therefore in quotation marks. Or apostrophe add o comma. Cabbage comma. We will give the age 15 comma and the class 2A. And instead of conduct close we put connect commit and we execute. In DB browser, so we see that the recording has been added. Now we will try. To add a list of students, so between brackets we will put tuples and between each tuple a comma. To add all the students, so we will use execute many. We keep insert into and student the table, and after values we will put a question mark. For each record now we will call after comma the variable. More students, which contains the students to add, and we execute and check in the database. we find the recordings that have been added. Now we will try to do a search in the database. We delete all that and we will declare a search variable. srch is equal, we will execute a SQL query select from student. In the student table, select all students with the condition where age is equal to a question mark. We close the quotation marks. After, we will put our condition after a comma and the condition in parentheses, and a comma after the number 16, so we will apply with print srch point fetch all. We will see the database. There are 1, 2, 3, and 4 students who are 16 years old. So we will run Python to find all the students who are 16 years old. To work with ollama in Python for running large language models locally, you must ensure proper setup and configuration. Ollama facilitates local execution of large models, including those from DeepSeek. The process involves installing ollama, setting up the Python environment, and interacting with the models via the ollama API or a compatible client library. In Google, we type ollama, and then we download it according to our operating system, Mac, Windows, or Linux. After downloading, we begin the installation. The normal installation is free. Ollama is an environment that will allow us to interact with DeepSeek artificial intelligence. Let's move on to the model. We'll choose our DeepSeek model. And depending on the speed of the internet, we will choose the version. So, I'm going to choose the second version, 7B at 4.7 GB. We move on to PowerShell. We will check the installation of ollama with the command ollama 2 version. I will copy the correct version from the site. Go back to PowerShell, type ollama poll, and paste the template. Press Enter to install. On execution, ollama poll. It will take time, depending on the version. We will ask ollama to run DeepSeek. And I'm going to ask him to calculate 10 plus 10. After thinking about it, he answers 20. Thanks to ollama, we were able to interact with DeepSeek on our computer. This is the objective of this first part. So, we're going to move on to the second part now. This is to install DeepSeek on our Python application. Then, we will create a folder named ollama. To install the environment necessary for the proper functioning of DeepSeek. Recall on the back, change direction to enter a folder. In the ollama folder, we run the command python vend. Here are the environment files placed in the ollama folder. and we start the installation with the command pip install ollama. I work with copy and paste to avoid mistakes. We open an empty Python file. On the site, now we will copy the usage code. And paste. We delete the chat response. The execution belongs to our workstation. Return to the site and copy the second version 7b. We run. Error, it does not support more than 2.1 gigabit. On CoPy DeepSeek 1.5b. We change the second version and execute. The order was executed successfully, and the response to why is the sky blue? We'll change to another question. Hello. He simply answers me. Hello, how can I assist you today? So that works. Now we're going to use another code. We will copy the streaming responses code. Put the first code in the comment and paste. We will glue and paste the same version of DeepSeek 1.5. Streaming must be true to have a streaming response. So we're going to change the question. Why Python is the best, and we execute. The answer is too long to read. So she interacted with our application. Now we're going to use Hugging Face. It's a model to detect humor in text. So this model can be used in machine learning. With Google Colab, we have a free cloud-based environment. This allows you to run Python code, especially for deep learning. We must first prepare our environment in Google Drive. New click More, then click Associated More Apps. There we find several applications, and we are interested in Google Colab. So we will agree to connect to collaboration. We type new, and then we see connected collaboration. In settings, I prefer to enlarge the text and do it in black mode, the dark theme. In Google, type in hugging face. We will choose our model and we will go to natural languages processing. We will click on text classification. And then we will open in a new tab the link distiller base encased fine-tuned SSD to English. Back to Google Colab, we will check the type of execution on the computer. So we have Python 3, we're going to use our default processor. We are ready, we will now start installing all the libraries. So we'll start with transformer. We always use an exclamation point at the beginning of each command in Google Colab. Then install transformer. The installation is successful. Now at the bottom we will approach the cursor and we will click on more code. And then we will type from transformers import pipeline. This is a utility function that simplifies the use of pre-trained models. It enables complex tasks such as translation, text classification, and text generation. We run all words translated by pipeline as positive or negative word are loaded. Now we will add the classifier. So classifier is equal to pipeline. We open the parentheses, we put classification text between quotation marks, comma. And we type our model as equal and we will copy it directly from the address bar. And we execute. Now we will test our program classified in parentheses. And we will give him a sentence to test the sentence, is it positive or negative? I love my son. And I execute. So it's positive immediately, with more than 99%. So it's correct. We will still use a negative sentence to test negativity. We type the same code and change the sentence to I don't like this chair. And we execute it. So it's negative with more than 98%. Now we will gather all the codes into a single program with a user interface. So we will import Gradio as gr. On va importer transformers import pipeline. so the same code classification is equal. We will try to copy and paste the code to avoid errors. Now we will create a function that will do the job of extracting negative words or sentences and positive sentences. According to the text, type in a text box. We will define an interface already present on Google Colab. And we will give it the value of predicted sentiment according to the entered text. Of course, input is equal to the text entered by the user. Is it negative or positive? And output the result as text. Launch to launch the text. Launch is underlined in orange. It has an error. So we have to type a period instead of a comma. And we execute. Here is our program that has been changed. We will give him the same question as before. I love my son. In this interface, we click on Send. The result is positive. We'll try the negative sentence anyway. We will try to apply online with the link provided by Google Colab. The answer is negative. This link is available for 72 hours. To use facial recognition, you must first install libraries. First, we will choose the working folder and we will add a Python file. We name it face recognition in the file setting menu, then we will click on the Python face recognition file. In the interpreter, there are several versions of Python available. If the code doesn't work, then it is not compatible, so think about changing the Python version or the interpreter. We will install the OpenCV library, then CMake. We will also add dlib. We will install the Pylo library. We will add the Immuta library. And finally, we're going to add facial recognition. We have everything we need to start our project. Now we will create a folder that contains several images and one image outside the folder. These are actors. We will import the OpenCV library through CV2 and facial recognition. Now we'll call the image that's outside the folder, img2. We will do a transformation of the image from BGR to RGB. RGB is a variable that will do a segmentation with OpenCV, or in other words, it will make a pixelation of the colors. Now we will create an img variable encoding equal to face recognition to face encodings. We'll give it the RGB variable. We'll index it by 0. We will display our CV2.im show image between apostrophes, the name of the image, and after the comma. The variable img CV2.wait key with the indexing of 0. We will apply. To the eye there is no difference, but Python has converted it well. Now we're going to copy and paste the code from the image and change all the variables. Instead of img, we'll put img2 and look for the image in the folder. So, I'll choose Leonardo. DiCaprio and then RGB to RGB2, img to img2, img to code by img encoding to img encoding 2. And finally RGB by RGB2. Result, it is a variable that will make a comparison. Face recognition. Compare faces between face encoding of image 1 named img2 and face encoding 2 of image Leonardo. Print between apostrophe result, comma result, and we will also display the second image CV2.m show between apostrophe img2, comma img2. For the second Leonardo image, it is inside the img folder. Before running the code, I always do a check with my eyes. We have 2 errors in our code, but I'll run them to show you. The code generator helps us finish our code, but sometimes it doesn't do it correctly. So we have to be careful. So we execute. This is only the first image that was displayed. The error is that comparing 2 lists is impossible. Our goal is to search for an image in a list. So we'll remove the braces. And if we run it, we find the second error. It's when we type our code, it added this line automatically. We delete it. Now if we run it, there you go. So we have 2 images that have been displayed and the value is true. Now we're going to try to give him another person. We're going to rename it to avoid mistakes. So we're going to copy Brad instead of DiCaprio and execute. Both images are displayed and the result is false. Now we'll ask our camera to perform a facial search on our img file. We import the NumPy as NP library for scientific computing and multidimensional array manipulation. And we're going to import OS. It's a library that provides functions for manipulating files and folders. In this code, we will use path equals img. This line defines a variable, path, which contains the name of the img folder where the images are stored. For images in curly braces initializes an empty list called images which will be used to store images after loading them. Class name equals curly braces, so it is an empty list that will be used to store the names of the classes to the categories associated with the images. And finally, img_list_grave has the os.listdir function, the files present in the directory specified by img. We will create a for loop that will iterate over the CL element in the img list that contains our images. And with cv2.myriad, we will read the images located in the img folder with the name CL. The image is added to the images list, and after os.dot_path.dot split separates the text from its extension, and in will be added to the class name list. Finally, we will display this list. Now we will create a find encoding image function. This function takes a list of images that detects faces in each image and codes them as numeric vectors. It will return these encodings for use in facial recognition to compare the image to the video. The result is stored in the variable encode list now, and then we will display encoding complete. Now we'll use OpenCV, CV2, to capture frames from a video source. The zero argument indicates that we're using the default camera. If you have multiple cameras, you can use 1, 2, etc. Now we're going to use an undefined loop, while true, which will process each frame of the video. Using the int variable, we will capture these images, localize them using the face location property, and then encode all these images. Now we will use the for loop simultaneously between two lists, encode current frame and face current frame using zip. At each turn we will retrieve the encode face, the facial encoding of a face detected in the current image and the position of the face in the image. With compare face, we will compare the encoding of the current face with all known faces. With encode list known, we will return this list of booleans indicating the potential match. And with face distance, we will calculate a numerical measure of similarity. And with np.argmin, we will find the smallest distance index in face test, that is, the index of the known face that most resembles the current face. Finally, we will create a condition, if match, so if we found the face, then its name will be in bold. With face lock we obtain the coordinates of the face with y1, x2, y2, x1. We will draw a rectangle on the image with a red color on the face, with a thickness of 2 pixels. In short, this code surrounds the detected face with a red rectangle, adds a red background at the bottom with a person's name in white letters. See video you just search so I think everything is okay, I will execute. She displayed the list. Already I see files which are in the list of images, which are not images, we are going to delete them. And we're going to run. Now the images are okay, he managed to encode them. Now I will try to write a picture among the pictures in the list. I will write Brad Pitt, she recognized it immediately. Now I'm going to see another one, George Clooney, so she recognized George Clooney.